Thank you very much for being here tonight. My name is Ben. I'm the co-founder of Iowa Level together with Jakub. First and foremost, big thanks goes to Kobe and Vista Print and Prague Software Craftsmanship for making this possible and for giving us this space and organizing everything. So huge thanks to you guys. Just wanted to let you know there's some sort of competition going on for the one who asks the best question. So you might get a ticket to a machine learning conference. So make sure you ask lots of questions. So without further ado, this is Jakub, the co-founder of iLevel, and he will talk about Roslyn and how to use it in the real world based on a project that's built on Roslyn. So take it away. Thanks.
So, hello, good evening. My name is Jakub, and together with Ben and a few students of Charles University, we are working on a project called PeachPie. And today's talk will be about how we use the entire platform called Roslyn from Microsoft to achieve what we do. Because a lot of people ask us, how do we do what we do? So, time to time we organize these kind of presentations, and we show them how we use this entire platform, which is Microsoft developing for almost 10 years, to achieve some other things that usually we cannot do. So, let's get started. First, if you get bored during the presentation, you can right now open this web page and try this technology live. You can try one of its use cases. You can see how you might get some PHP code running on .NET right in your web browser. So during the presentation, you can experiment it with the technology a little and try things we will be showing in the presentation. Sorry. And now, let's get started with some history, because everyone loves some history. And actually, let's get started with year 2004, because in this year, there was a few students on Charles University started a project called Phalange, which compiles PHP code to .NET. They tried to prove that you can do things better and faster and say some trees or so. So they were working on this project for like 2 years, and this is actually the beginning of everything, because some of these students are now working right in Microsoft on the Roslyn platform, and what they've learned in here in Prague on this project is what we see in the real world, in Visual Studio and C# and everything, what you can see today. Anyways, a few years later, the Roslyn project started, just internally. It was not open source, just Microsoft starts doing first steps. And 2 years later, there was some technology preview. They showed what it does. And a few years later, it was open sourced, added to so-called .NET Foundation, which is organization of all the open source .NET or Microsoft projects all together. And a few years later, it was put on GitHub and ready to be used. Then we just started doing our project PeachPie, which is based on the entire Roslyn platform. And this was the right year because Roslyn was like ready to be used for other projects. And right now Roslyn is capable of what it is. So it took like 10 years for Microsoft to do the entire platform. So it's really a huge project, and it's not easy to show you how it looks like because it's a platform. So I try a few images or a few diagrams to describe you what it is and how you can use it. So this is the first picture we can see today, and that's how Roslyn looks like actually. So you can see it's a framework. It's not something you can see, but it's a framework, and it's real hard to show all details. But this picture shows you everything it's capable of. First it's a complete compiler. You can know it because it powers all the developers of the .NET platform are using this technology. And what you might know from your experience is the upper part of this picture. It's called language service. It's what all the developers see when they develop a code in Microsoft's development environments and also other environments, because now it's open source, so they can use it. It's things like colorization of your code, helping with code completion, formatting of the code, analyzing, navigating to different functions, and so on. There's these little tooltips when you mouse over a piece of code, so you can see what it is, and so on and so on. A lot of features you just use it and you don't know about it, like you're running your code and you can change it during the debugging. It's called editing continue. So that's all the little features that are possible thanks to Roslyn platform, and that's what you can see when you develop a code. Under this technology, under its features, there's like an entire framework, entire APIs of the Roslyn. So like every framework has some APIs, every framework has some rules. Here is the same. And it's very important that no matter what is implemented using Roslyn, the API is the same. So all of these boxes can be used across all the languages that are powered on Roslyn. So, if you take a look on the middle part, you can see it does things that usually you don't have to care about. Like it understands the code that the developer is writing, and it parses the code and creates so-called syntax trees, and then it maps the code to so-called symbols and semantic trees, and it does some flow analysis, some other analysis things. So you can see it when you are developing. It underlines wrong code with red lines and all these things. And thanks to Roslyn, these things are extensible and they work. So that's like most important. But most important is what we can do with it. So first, if you take a look on the picture, you just don't see the whole image of the framework, because the framework is something you cannot see. So what you can imagine if you hear something like a Roslyn. First, for people like me, it's a template on how to create your own language compiler. So it's a cookbook on how you can translate some language to something that computer will understand, especially like the .NET runtime will understand. So you can take anything like PHP, Java, JavaScript, and using the Roslyn platform, you can translate it to the .NET and make it compatible with everything what's compatible with .NET. Second, like one of the reasons why Roslyn came out is some analysis framework. So everything what runs on Roslyn, like C# language, can be analyzed using Roslyn. So there's a company called, for example, ReSharper. A lot of people know ReSharper because it started as an analysis framework for the C# language. And what Roslyn allows you to do is like do all the features that ReSharper does and analyze your code by your own without using ReSharper, which is nice, and that's one of the reasons why Roslyn came out, because it allows developers to create these little analysis things for your language, like C# by themselves, without using commercial things like ReSharper. But on Roslyn, there are like tons of really smart people in Microsoft working on it, and they really love to create highly optimized and really cool data structures and algorithms, and they just put it into Roslyn. So if you go through this whole Roslyn internals, you can see a lot of really smart things, really smart components, smart packages, smart algorithms that you can use, because Roslyn is meant to be like the fastest compiler ever. Next, because it's so important for people to be able to write the code. The next reason why this happens is Microsoft has to create really smart language editor, really smart code editor for you. So he builds entire language service, so-called language service, or code editor with all these smart code completion features and analysis features on top of it. So everything which is powered by Roslyn can be analyzed and edited in a really nice, fast way. And one of the next thing is you can use some other, like there's tons of APIs, so you can use some other APIs and like compile your code like in memory and without running anything like Visual Studio and so on. And you can just take a piece of code and compile it in memory. So these are like tons of small APIs that are capable, that are included in Roslyn, and if you know them, if you need them, you can use them. And finally for us, the most important thing is it creates something that can be executed, something that can be deployed to the server and that runs and can be integrated with other .NET things, other .NET languages like F#, C# and so on. So if you build something on Roslyn, it creates DL files and exe files that are fully standardized and compatible with everything else produced by .NET tools, .NET things, Microsoft, and so on. Anyway, what does it mean for users of the Roslyn platform, which are usually developers, right? First, what we can do is we can just take these little pieces, these components that were written by smart people, and they are available for free, and we can just use them in our application. So we can legally steal work of really smart people in Microsoft and use it in our way. We can talk later about what's possible with it. What most people do is they extend their business logic and business applications with custom analyzers. So they are able to write for their company a custom analysis and custom tools and do things like detect anything wrong in their project and automatically changes to something what is not wrong. So this is the most usual case where you extend Roslyn using its analysis APIs and create some analysis, like you are not used to have lowercase names in anything, so you can just change it. That's the most usual case. And in our case, you can just touch all these pieces and change it to something else and create a completely new product, which we did. So there's the last use case of the entire platform, and that's how you can, for example, build your new entire language support based on Roslyn. So in our case, we picked PeachPie language because PeachPie language runs on most of 80% of the web servers, more than 80% of websites on the internet. So that's a great add of changing it to something else. And if you remember the first slide, what is Roslyn and how it works, you can achieve that by just translating the PHP code to these Roslyn symbols, which is not important, but that's like the only thing you have to do. And the rest is done by the rest of the platform. And you have these .NET things, .NET DL files that can run anywhere where .NET can run, which is actually like PCs, Macs, Linux, mobile phones, watches, and servers using these ARM processors and anything else. So it's really a great way of changing something old to a .NET and making it working everywhere else, and make it compatible with everything else which is a part of the .NET. So this makes your language, for example PHP, compatible with C# or F# or anything that runs on .NET Core, which is several other languages, or make it compatible with every project that is part of Microsoft.NET Foundation, which is the open source foundation containing hundreds and hundreds of projects that were first open sourced by Microsoft, and now they are accepting more and more. Also, make it running on the Microsoft, or I shouldn't say Microsoft, but it's open source technology of web servers, and currently it's the fastest one on the market, ASP.NET Core. Or, for example, Samsung Tizen, which powers Samsung TVs and watches and so on. So, by using this Roslyn platform, you make your code compatible with all these technologies, and they can communicate together and they can run within the same process, and so on and so on. You make it literally one same language. So this was theory, a lot of slides, a lot of pictures, and we should see. And we should take a look on how it runs in the real world. So I have a first demo in here. Let's see how it works. It's just two hands. And yep. Okay. So what we did is that we transformed the old PHP language to .NET thanks to Roslyn. And the experience for users is pretty straightforward. So anyone who has like in the company or anywhere else some projects in let's say in here, in this old language called PHP. You can take it and pretend it's not PHP, and you can pretend it's C# or it's any other language in .NET. And work with it like that and make the other components, the other projects in the C# language working at the same.
Jacob, should we see anything?
Mm-hmm. Bigger? Is it fun? So in here we have a code in PHP, which usually means you have to install some PHP on your computer and you have to learn how to work with PHP, and that's like pretty much it. You cannot do much more with the PHP language. There's plenty of websites and plenty of components in this archaic language, and it works pretty nice. But what if you need a little bit more? What if you need to boost its performance, or you need to integrate it with something you have in .NET and C#? In other things, then you can use the project PeachPie, which is built on Roslyn, to compile it, to transform it to .NET, and let the rest of the platform to believe it's .NET. It's not PHP anymore, and it's .NET. So in here we have a sample code, and the rest is the same. The rest is we can go in here and start a project like it's .NET. Yeah. And what happened is that the entire editor, the computer, thinks it's a .NET project. And it compiled it for me. It created the DLL file, or in this case, the executable file, and it's running it like it's a normal program in C# language. And then it starts debugging using the .NET debugger instead of some PHP debugger. I loaded some stuff. That's what he does. And even you see it's PHP code, the rest of the code editor, the rest of the software thinks it's a .NET actually. So we can do the same things as we are used to, stepping into, stepping out, and continuing, seeing the result, and that's it. That's how it works, just like that. But instead of your usual experience with PHP language, you have the same experience as with the C# language. So as a result of these actions, you can see some newly created files like a DLL file, and some PDB files and some other files. That's what you get if you compile C# language if you compile C# language in general. So let me make this a little bit bigger. Anyway, so what happened is the compiler, the Roslyn compiler, created the DLL file no matter what the input language was. And we can take a look on the result. So what we see in here, Roslyn can take this code, no matter what it is, and create a DLL file, which is compiled something, and then you can decompile it back to, for example, a C# language. So it doesn't see a difference in what was before the compilation. Anyways, it creates something like this, and the point is we don't have to understand it because Roslyn does. We just have to know that it can do it. So we feed it with these symbols and with these syntax of the input language, and it creates us this. And since it even doesn't know it was PHP before, it thinks it can transform it back to something like C#. So what we see in here is the PHP language basically transformed to a C# language. That's the first use case of this thing. Then also it creates for us these files, PDB files, and this is information for the debugger of the language. So then the Visual Studio and other tools understands what's inside this DLL file and allows us to step through the code and do other things. And let me see what else. And also it creates the entire structure of this code and the entire DLL file. So so it understands how it works, and by creating these files, you can be always sure it creates like the newest and most optimized version of the language possible. And since these conventions and these standards are always changing, it's great that there's this Roslyn thing maintained by Microsoft, and it always provides me with the latest versions of these like standards, because as we will see later, there are like tons of tools and tons of other programs that are utilizing these results for other things like performance diagnostics and analysis and development tools and so on, allowing us to create toolings for completely new platforms and languages like the PHP language. Okay, this is really small demonstration of translating some small piece of PHP code to .NET, and that it works. But usually people ask why we do it. And the answer is, PeachPie language is really well-known thing, and a lot of hosts, a lot of web providers are trying to avoid this language. A lot of companies are trying to avoid this, mostly Microsoft-related companies. And also it's known for some lack of performance. And by compiling something to .NET, you can be sure Microsoft will work on its platform, and they are improving the performance a lot. Like in I think 2 months, there will be a new version of .NET which will improve performance again about another 20% and so on. So once we translate something to .NET, we can reduce overhead of the web servers. We can allow them to serve more customers at once and lower downtimes and lower the response time. The other thing is there is a great security enhancement on the .NET platform. So by using this, first, if there's this step of compilation, you basically don't allow to modify source codes on your live server, which is like a great security enhancement. And most of attacks on the websites are based on modifying the source codes on the live servers. Then, as we'll see later, you can integrate everything with other projects and make one language compatible with everything else you have written in your .NET solutions. The other thing is it works everywhere. Like you can create games in PHP language if you want. You can develop some IoT devices in PHP language, or you can take existing components in PHP or take PHP developers and let them working on IoT, which is great because you can literally use a technology that was meant for web servers, use the know-how of developers working on PHP websites, let them doing the same on these cheap, smart IoT things running on .NET Core, which is not possible with regular PHP or other languages. So if we would be able to do this the same with, for example, Java or JavaScript, you can have IoT devices powered by PHP developers, which is a little bit controversial, but like half of the users desperately needs it, desperately wants it, and the other half is trying to avoid it. So we will see how it goes. And the last thing is by compiling something to .NET, you make it like packageable into so-called NuGet packages. So you can make your applications structuralized components and being able to update it very fast and securely through modern technologies, which is not again possible with the existing platform. Anyways. Let's see the next demo in here. Because what's really cool about something that runs on the same platform as something else is it works together. here we have the first real demonstration. In here. Again, we have in here we have an application in PeachPie language, and at some point we want to transform it or extend it in C# language, because we prefer C# over PHP, of course, and this allows us to do these kind of things. So in here we have real standard application. You can imagine it's an API for your platform, and you just need your customers, for example, to use it in a C# language. And what we do is we keep the same thing in the PHP language as we had it in before. We have some code that creates users, for example, and tries to authenticate them. We have some logic of the user in here, which has a name and has an email and some profile URL. It's able to create itself, initialize it, and then he authenticates himself, for example. So this is a thing we had in the PHP. And in here we have something new in a C# language, and we want to use it. Like before, you would have to create some APIs around it and communicate through network to be able to use it. But if you compile the old PHP code to the same platform as you are working on, like in here, you can use it directly in your C#. So what we have in here is a typical C# project. Every project has its so-called project file, which is this one. And every project file has what it is. It's an executable file. It has some target framework, which says .NET Core in this example. And every project file has something like references to other components, other projects. And in this case, we reference the PHP project. So now we have to reference a PHP project from the C# project. And the PHP project is this thing, as I showed you before. It's also a project file, actually, but instead of, let's show you this example. Instead of this line at the top saying Microsoft.NET SDK, it says it's PeachPie.NET SDK, which is slightly modified project descriptor from Roslyn. Now it serves like a project file for PHP files. So instead of calling C# compiler, it calls modified Roslyn compiler that understands PHP language. And its content is pretty much the same. Instead of executable file, it's a library, and the rest is just for purposes of description and packaging. It's not important. But what is important is it compiles PHP files instead of usual CS files. So this is the project file. This is a project file for PHP projects, compiling the PHP projects to DLL files. And this is like everything you have to do to migrate, to upgrade PHP projects to .NET. And since then, you can reference the project, you can take it as a dependency, you can just use it. and use it as any other C# or Visual Basic or anything else you are used to. So we can see, for example, the thing, this one. And if you get started using, again, .NET, somewhere at the bottom you can see it's doing something, and here is good. So in here you can see it did some compilation. It's not important. Important is it's all the same process, but it's all .NET running your C# and PHP together like one. So for example, in here we are in C# language. If you are used to it, you are just in your natural environment. And let's put some breakpoints in PHP code. Here. And we can step through another language, step through and go to a PHP language. So in here, if we can see like this one. So in here, you see we are running the same application without any interruptions. We are in C# and going like seamlessly into a different language. But since it's all built on Roslyn and since it's all built on the same platform, the editor, the Visual Studio doesn't see any difference. So we are stepping through these different languages as one, as the same. And we can continue like that, and we can step further to the C# language, for example. So let's step over and in here. In here, yeah. And now we are stepping from C# to PHP and back to C# to another function or anything else. Within one application. So this allows us to slowly or seamlessly remove portions of the old PHP applications. Before we had this little thing, this function, written somewhere in here. But we could just comment it out, remove it from the old code base. For example, it's possible it was slow or it was insecure or unsecure or just we didn't want it in a PHP language. So we just removed it from the old code base and sorry, in here. And we just created the function in the C# language because it was faster or there was already some component or something ready for this task. So we just used the C# language for this and removed it from PHP code, and we didn't have to change the original PHP code. It's still there. It still thinks. It's calling the old component that was there before. We just suddenly like replaced it with the C# language, and in this way we can replace all the parts of the old PHP application with the C#. So if there is a class or entire component in PHP language, and we want our old application to like subsequently transform it into the .NET application, we can just subsequently remove files from the PHP project and create them, for example, in C# or replace them with something that already exists in C#. And in this way, slowly cut pieces from the old application to transform it into a .NET, instead of like taking 2 years of work and rewriting everything from scratch, which is the usual use case what our customers do actually. They can take their old legacy code base and slowly move and slowly transform their projects to .NET using this approach. If we step further, I think there is one more example here. So in here we are in the .NET, we are in C#. And this is another example. We can also extend objects written in PHP with the C# language. So this is the definition of user. And you can take this user and extend it with the C# language like usual. So you can create a C# object called, for example, .NET user, and extend from this PHP user, and continue programming as you are used to in a C# language. And you can do the same in the other way. You can extend your .NET user in PHP and make .NET user a base class for your PHP user class the same way. So this is also like very useful when you have some logic in PHP and you want to continue or extend the same logic in the new language like C#. I believe we can put some breakpoints in here. Let's see what happens. Okay, so if you step into this .NET user, yes. So in here we are creating .NET user. It initializes the .NET user and continues in here. Then it calls some function in the .NET user. So it stops in here and it calls the base authentication thing, which is implemented in here in PHP. So again, from here we can dive into the PHP language again. So we see we are starting in here to the object that extends the PHP object, and it calls back to the PHP in this way, like very seamlessly without any overhead. And anything else you have to actually do. It's just from this point of view, from this C# view, the PHP objects look like they are in C#, and from the PHP view, the C# objects like this one, they look like they are in PHP, but they are in other completely different language. So, step 3, okay, it's finished. And this is how it works. Basically, thanks to Roslyn, because it makes the PHP code looking like it's C# code. We can also take a look on how it compiles, but I guess we can check it after, like let it break and after break, we can take a look on some bigger applications. Like we have prepared, if you know WordPress, for example, we have prepared a demonstration on how we transformed entire WordPress CMS to ASP.NET Core, and how we diagnose performance and other features of this CMS platform. So let's break for a moment. Yes, so let's continue with some real-world demonstrations. In here we have, it's called Kestrel. Kestrel is a pretty new web server. It's a pretty new server from Microsoft. So, it's a new platform, it's a new web server from Microsoft. If you take a look on some benchmarks, like tech-powered benchmarks, you can see it's like, it's actually the fastest web server that currently exists. So the Kestrel, and it's powered on .NET. So basically, if we take some code in anything like PHP and compile it into .NET, we can take advantage of this Kestrel web server and make it running like as fast as possible. So let's take a look on another demo in here, web application. If you're a C# developer, this is everything you have to do to initiate your web server on Kestrel. This creates a web server that consists of like a pipeline where you can dynamically add features like they serve some static files, serve some ASP.NET files, and now it's possible to tell him in here, hey, use some or handle PHP files as well. So this is standard things you can see in the documentation of the Kestrel web server. Here we are saying to handle static files, to handle default files, use sessions, and so on. And we have added the API to use PHP or handle PHP files as well. So if you run this thing, it starts a web server. Here. And what it does, it handles requests for anything that ends with .php. Okay, good. And I guess is anything that that ends with .php and passes it to our compiled script. So request so without having any like PHP runtime on my computer, if I make a request to this port, which is handled by the Kestrel web server somewhere in here, yeah, it told me it's this URL. It passes the request to the compiled PHP script, and since I have a breakpoint in here, it deposits in here. So let's continue with the script. Instead of usual, this is like a command that in PHP that writes information about your PHP. So instead of having the typical PHP information page, you have this typical PeachPie information page, which is just for demonstration. Anyways, this is how you can integrate PHP compiled to .NET running on this Microsoft Web Server Kestrel. So if we take like together everything we saw right now, compiling stuff to DL files and integrating to Kestrel web server, and in here we can see you can configure the web server to some rewriting things to something else using the Kestrel APIs and everything. And these .NET sessions, which runs actually pretty fast because they use distributed memory implementation instead of files and these old stuff like it's still done in PHP. You can put it all together, and we can take a look on a bigger application on this WordPress link. Just let me see if you don't have anything else. Yes. This is our next the WordPress. So let me close this. It's nice. We just do a code this nicely. Let me start. Or let me open the full-blown Visual Studio in here. Change it a little bit bigger. Not that big. Good. And let's open the same in this full version of Visual Studio. This Visual Studio 217. And we can see the same in here. So I'm a C# developer, so I have created a web server, the Kestrel web server, and I would like to run a full WordPress on it. So we created this project file, as we saw before, but targeting PHP instead of C#. You can see it's PeachPie SDK, not Microsoft SDK. There are some things you don't have to care about, but you can see we are compiling PHP files and targeting .NET Standard, which is .NET Core. Actually, we are saying this project is under GPL license, which is very important. And that's it. We can also from the PHP project we can make references to C# project. So we have some reference to this project. So we are able to extend the project with our .NET objects, as we will see later. Anyways, if you open this thing, it's a usual WordPress. Download it from the WordPress.org site with no modifications. So you can open its content files in PHP, and you don't even have to care about the PHP code in here, but I'm just showing it because to see it's there. So all the PHP things we don't have to care about. But what's new in the world of like WordPress is we can right-click on the project and build it. And this initiates. Wait, it was fast. It was too fast. So rebuild it. And what happens is first it compiles the dependencies, my dependency shell project, but now it runs the PeachPie compiler, which is like modified Roslyn compiler, and it does all the steps we saw on, I think, the second slide in here. So it parses all the source files of the WordPress. It creates all the Roslyn objects like Roslyn symbols and Roslyn semantic trees and everything. It runs the Roslyn analysis over the code. So you can see it detected a few issues with the WordPress. Like there are some functions and classes that actually doesn't exist, or they are calling function debug, which doesn't exist. So they have a lot of issues that were found actually by Roslyn. Also in here they are creating a function which they shouldn't, and in here they are using an object that doesn't exist. So Roslyn actually found a lot of issues in the WordPress, which might or might not crash during the runtime, and it's pretty good to know because in the world of PHP you are usually not checking the code before you are deploying it to the live server. You are just waiting for things to happen, and then you solve them. So in here we can let Roslyn to find out and to diagnose the code before we are going to publish it to our web server. For example, in here again they are using a class that doesn't exist, or an object doesn't exist, and so on and so on. Some variables that are not defined, so this code will never work. In here, this is deprecated, it doesn't exist at all. False. Undefined. Oh, sorry. Anyways, even though we are able to compile the WordPress and leave it as a warning for you as a user, so you get to know there will be issues, but you can still run it, and you can still run it and inspect the issues. Okay, let's run it. So let's see what happens. Okay. So now everything compiled, and the first thing which is noticeable is it compiled like in 5 seconds, which is great because if you remember some other companies attempted to compile PHP, for example Facebook, their compilation took like an hours because they translated the PHP code to another language, to C++ language, and then they tried to compile the result in C++ language. And they were working on it for years, and after they had to change it to some kind of virtual machine. So this is really great because it took like 6 seconds, which is awesome. And the result is like a normal WordPress, as you know. Where am I? It's normal WordPress. There's nothing else you can see. It's just the same thing you would see if you run it on PHP, except that I don't have any PHP on this computer. So if you take a look on my task manager, or how is it called, there are some photos. There's no other P in the task manager. So there is no PHP. There is only thing called .NET somewhere here. Do I have .NET? It's under Visual Studio. So there is only .NET running, and this site runs on a server that's only powered by .NET. So it runs great on Azure, Windows servers, and so on and so on. And you can do like funny things with your WordPress installation. Like you can add things to your dashboard using C# and Razor partial views. You can create and extend the mechanism of WordPress with C# plugins, for example. Or you can take the WordPress plugins and WordPress widgets and use them in your C# application. I believe I have some things in C# here. Yeah, for example, we have some plugins for WordPress written in C#. So let me just find it. Written here. It's in here. So we are, for example, extending WordPress dashboard with the C# code. So once we requested this plugins page in the WordPress dashboard, it actually called C# code in our application. So as we step through the code, you can see that now we are in here. We are in C#, but it started in here in PHP and again PHP. So even the debugging experience is the same as you are used to from the C# language. And then it up in here in C# where we can do our things. For example, in here we are overriding what you can see in the plugins page. We are overriding with our own results that we take from NuGet server and so on. So since we know C# better than the PHP, we prefer writing things in C#, and in this way it allows us to extend the WordPress page with our C# code. Cool. But what's next is this right part of Visual Studio, because anything you run on this .NET platform in Visual Studio gets this nice diagnostic tools, and you have it like out of the box. So anything you transform to .NET using the Roslyn gets its own performance profiler. And that's great because we don't have to do anything to provide performance diagnostic tools for the PHP language into Visual Studio. It just works out of the box. And in this way. You can, for example, watch what your CPU does when you are browsing through the WordPress. So you can find bottlenecks, you can find and see what's causing the most performance overhead, and then fix it, of course. So in here you can just select part of your timeline, and you can see what components, what functions of your application, now including WordPress, causes you the most performance overhead. And use these nice diagrams to browse through the code tree of your application and see how many percent of time is eaten by specific functions of the entire application. So in here we can see just rendering the title of the plugin takes about 17% of time, which is something you can, for example, report to WordPress developers to make it faster. And this leads us to the performance, because this is the most frequent question we have about WordPress and compiling WordPress and running WordPress on .NET, and that's the performance of the entire thing. Right now, the entire project is like in version 0.9, and the performance is pretty much the same or a little bit better than the performance of actual PHP. And most of the performance gain we have from the .NET itself, because part of the .NET is a thing called just-in-time compiler, and that's something that compiles already compiled code to the machine code of your actual CPU, and it makes most of the optimizations. So if you compile something to the DLL file, it's not the final form of the application. The .NET runtime and the just-in-time compiler takes it, and all the instructions are compiled again to the machine code of your CPU to make it even more faster. So if your CPU has some additional feature like vectorization or some specific instructions, this second compiler is able to make use of it and make it as fast as possible. Also, Microsoft is working real hard on this runtime and making it faster and faster every half year. So in a month or two, there will be another big update of the .NET itself, called .NET Core 3.0, which will allow us to run things even faster without us having to do anything, or without you having to do any changes in your C# code. Mainly it will utilize the memory better, so you can run more things on your server and it doesn't have to clean or collect the garbage in the memory so often. So these are the great enhancements done directly by Microsoft, which will allow us to run things even faster. So right now, these things or this progress thing runs like that's the same as you would run it on PHP. But there are great improvements on progress. So the potential is really big to run it much more faster. And thanks to diagnostic and similar things, you can see immediately what has to be done and what has to be improved to make it faster. One of the final things you can see characteristics is if you compile something like this, here, right here. So there is a little line in this project file, and it's actually here. Right. There's a little line saying generate package on build, and it means without us or anything else to do, it automatically, or you compile the process and the Roslyn and the things around it will create so-called NuGet package from your project. So after it compiles the WordPress into a DLL file, it packs it and sign it with private keys into a NuGet package. So in this way, as a result of this, all of this actually, you have this little file with the extension NUPG, which contains the compiled WordPress. And you can publish this package to sites like NuGet.org or similar, and you can make use of it, and you can reference this package as it is, and use it in your application. So if you create an ASP.core application in, for example, in Visual Studio, you can just add a reference to this package, which is online. It's called PeachPie.wordpress, and that's all you have to do to have WordPress in your C# website as a front end. And the great thing about it is it doesn't contain any source files of WordPress. So the package contains only this compiled DLL file, so it's kind of obfuscated. It's kind of the source files are like hidden, and also you cannot change it without breaking the signature, which you shouldn't be able to do. So in this way you can publish, you can, for example, give your clients or give your users a package of your PHP application without them seeing the source code, or without their users or their hackers to be able to change the original source code of the application. And this is one of the great things, because a lot of PHP companies are trying to hide their source code using so-called obfuscators, but basically it's not possible in the world of PHP. So this is a great way of deploying your PHP project without giving the source code out to hand. I think that's it. Yeah, last thing. So that's pretty much it. That's how we. That's what we did. That's what we integrated, and that's how we run the entire WordPress on the .NET platform. And if you have any questions, I've heard there's a competition. Some questions, so if you have some good question for us, let's begin.
Okay. How do you resolve types for the PHP symbols? Because PHP is a dynamic language, .NET is strongly typed. So do you just throw dynamic all everywhere, or do you do some type difference?
It's a great question. So for now, it's the best question so far. Yeah. Thanks to Roslyn analysis and thanks to other analysis algorithms, we are able to resolve types for most of the variables and most of the class properties. So even the data fields are not typed. Even the original developer didn't specify this is integer, this is string, this is anything else. Most of the types are resolved during the compilation phase and during the analysis. So most of the types are resolved during compilation, and the ones that are not, like sometimes PHP developers use a variable for multiple types by purpose. They assign a 0 to it, and then assign a string to it, and then they use it as an object, and then they use it as an array. We just have a special type called PHP value that is basically a union of numbers and strings and an object type, and it can hold multiple types at once, and it remembers what type it is inside. So for most cases, we resolve the type. For the rest of the cases, we remember it as a union thing, something like a dynamic in the C# language. It also is able to hold things, but we try to avoid boxing as much as possible, which is the operation of packing integers and other value types into objects. So for these purposes, we don't use dynamic as C# uses, but we use this special union called PHP value, which we can like take a look on it later if you want to. And that's pretty much it.
Is it support to php.ini files for the configuration? Like, for example, maximum execution time or memory limit?
So one more time.
Is it support to php.ini files? php.ini, I-N-I, for the configuration. Okay, I'm trying to loud. Is it support the php.ini files for the configuration, like a maximum execution time, memory limit?
Yeah, the configuration is completely different. So configuration is based on JSON files. It's using this typical .NET app settings.json file. So we have mapped the PHP init configuration directives, like the encoding thing and enable extensions and so on. So we have mapped it to the same settings, but in app settings.json configuration file. So like yes and no. You cannot just take the php.ini file and use it. You have to like think about it and rewrite the init settings to the JSON.
Now I have put those unresolved variables or classes, I mean these errors during compilation, how the compiler
How the compiler
handle those undefined classes or stuff.
Undefined classes, yes. So PeachPie runtime has to keep track of anything that happens in the code to simulate the lifetime of PHP application. So even if you don't have to, usually you don't have to keep track of declared classes in your C# application. In PHP application, you have to keep track of what was actually declared and what wasn't yet. So basically we have a dictionary of declared classes and corresponding .NET or CLR type declaration. And if compiler doesn't know the class, like it underlined or it reported the class is undefined, it compiles as something dynamic, like very similar to to C# dynamic thing. It compiles to something like assembly.getType. It tries to locate the type in runtime, and then it tries to use it. And if it doesn't succeed, it just throws an error and it crashes. But you are warned during the compilation time if it happens. It's like your fault. So anyone else?
Just approximately, how many hours you invest in this project? Like not you personally, but only like huge piece of work.
It's really, that's not easy question. Like the Roslyn, because Roslyn itself is several millions of lines of code done by people that actually started this project. So it's like several millions lines of code from Roslyn. It wouldn't be possible without it. And when it was started on the Charles University in like 2004, it was 1 year of 5 people work. And all the knowledge they had was actually used for this project. So like there is a lot of know-how, a lot of work before. And this is 2 year work of several university people. So it's a lot of work. If you imagine a PHP language, it's in development for like 15-20 years, maybe like that. So it's like 20 years of work did in 2 years. Something like that. It's 2 years, let's say, plus the work before.
So you actually inherited all the stuff from the Charles University?
Yeah, it was taken, reused, re-implemented, but without it, it wouldn't be that fast. It helped a lot, so it's hard to say.
And you mentioned that the people left to Microsoft, right?
Yes, when people started it, the idea left to Microsoft. They were hired like immediately.
And did Microsoft try to buy your company?
We are not like it's not recommended. I was told it's not recommended to talk about it. No, but it's supported. Like people in Microsoft love it. On their Twitter, you can see they always love it, and they support it using this .NET Foundation organization, which is the organization for open source projects. They provide free hosting, free Azure, free continuous integration server, and so on. So they help with marketing, with PR, and some conferences. So they try to support the project as much as they can.
But you definitely help them, like, people to decide where to move from PHP.
Mm-hmm.
So your project, they decide to Microsoft.
Yeah, basically this allows companies running on PHP to move to Azure, to move to the .NET platform. That's the main point. Mostly companies having like a lot of code in PHP, they are able to still use the code in PHP but run on .NET, and they can use like components. If you have, for example, your entire tax or financial records maintained by your PHP application, you just need the same logic in your new application, so they can use the old stuff from PHP and use it freely in .NET without this 2 year window where they would have to rewrite everything to C# and hope it will work the same as before.
And you force them to go to C#
This will help. Yes, this will help them get the decision.
Right. The performance comparison, real code performance comparison is like 0.9, as you say. or is because in this case of CMS application, in most cases the database is the bottleneck, and therefore even if the PeachPie will be 100 times faster, it will speed up so much the application in the result.
Yeah, the database might be the problem, but since that's one of the advantages, since this is running on .NET, we can take advantage of async everything, so async calls, async databases. So it helps with the database a lot. Also, it all runs in a single process, so we don't have to forget about everything when your web request ends, and then connect again and so on. But we can have much better these permanent connections to database. So the .NET helps a lot with this. But if we do the benchmarking of the performance without databases, there is still a lot.
I would guess that the most benefit would be in some number crunching type.
Yes, definitely. Like if you want to compute pi or factorial in PHP, we are like 100 times faster.
Yeah, I would get something like it, but yeah.
Yes, that's true. Also, thanks to the Kestrel web server, we have much more concurrent requests possible, and the overhead around the web request is much smaller than with regular PHP, so that helps as well. So even for the websites, or we are much faster than PHP.
You said that it compiles PHP using some async pattern, so it introduces some state machine into the function to be compiled as async or something like those.
Yes, we are doing this like these database calls, not in general.
So it is
Yeah, so it depends. Or it's open source, so you can take a look on some. There's this website, this try.peachpie.io, and you can experiment with it. You can put pieces of PHP code down on the left, and you can see how it looks in the .NET. So if you see something you think you can compile better, you can send us like a sample code and we can take a look at it, because there's a lot of opportunities for it.
How about some PHP extensions that use some machine-dependent code, like for example, I remember something about image magic or icon. So how do you migrate that to that?
So basically, we have to rewrite all the PHP extensions to C#. We just don't use the original PHP extensions because they are written in C language, and it's not safe, and it's unmanaged, and we just cannot use it from the .NET Core. Well, and so we have to rewrite them. So everything we did rewrite is working. Things like CURL or image or GD2 extensions are written as well. But these, as you said, the extensions that are like called externally from the code, I guess we haven't tried, but it's possible because they are just external executables that are run from the code, so you can just run them. Then you don't have any improvements over your old PHP applications. You can just because they are native executables, so it would work the same as before. I think that like the most advanced question was the type system of the PHP. So I think the first question is the winner, actually. And